All right. So I think we can start now. So hello everyone. I hope you're doing good. Today's event is Cybersecurity Active Directory Penetration Testing webinar. It's an event where our speaker will introduce us to one of the most important domains in cybersecurity. Today's speaker is Karim Rida. Karim, a fifth-year engineering student at the Lebanese University Faculty of Engineering and second-year engineering student in the cybersecurity and data science fields at Telecom Paris as a part of a double diploma program. He is the winner of the Huawei 2019 IoT Internet of Things Middle East Regional Competition and former president of the Cyber Community Club and the Lebanese University Faculty of Engineering, where he was a part in provisioning the current curriculum used in the club and organizing numerous workshops in collaboration with different national and international cybersecurity companies. Alongside his cyber community colleagues, he participated in numerous cybersecurity competitions nationally and internationally with moderate success. Guys, all useful resources will be available in the description of this event once uploaded on YouTube. Please, if you have any requests, just raise your hand and write it in the chat box. Karim, the floor is yours.
Thank you, Hadi. I hope you can all hear me.
Yes, all clear.
Okay, so I'll start by sharing my screen.
Sure.
Okay, so I hope you're seeing my screen.
Yes.
Okay, cool. Okay, so as Hadi told you, today we're going to talk about one of the most important domains or ideas in the cybersecurity domain, which is Active Directory penetration testing. So we're going to start about talking what an Active Directory actually is, what is the definition of an Active Directory. Then we're going to go into what are the elements of an Active Directory, what are the physical elements, what are the logical elements of an Active Directory. Then we're going to talk about two main protocols that we usually see in an Active Directory, which is the LLMNR protocol and the Kerberos Protocol. We're going to talk about how these two protocols work, what they achieve, and in the end, we're going to talk about how to crack, how to attack these protocols, and how to benefit from these protocols. So to start with, we're going to talk about Active Directory. But before I show the definition of Active Directory, does anyone is anyone familiar with this word, with the word Active Directory before starting the session? If anyone has an idea, just open the mic and speak.
Just raise your hand and open the mic, guys. So it seems no one has an idea about it. Ahmed.
لا صراحة. No, we don't have an idea.
Okay. So an Active Directory is an access control system for Windows. Okay, I think you all are right now. Okay, what does an access control system mean? Well, an access control system helps restrict access to resources. So, for example, let's say I'm in a company, and the company, of course, has many computers for the employees. So the idea is that each employee has a username and password in the company database. So what he does is he enters the username and password, and he is allowed to use the computer of the company. So the idea is this action, the action of entering the username and password to access the resource, which is the computer, is what an Active Directory is. Now, when we talk about an access control system, we talk about two main words, which is authorization and authentication. Authorization is the permission to access a resource. So do I have permission to access this resource or no? What are the permissions that I have? Can I read this file? Can I write in this file? Can I add something to this file? All this is called authorization. Authentication is the ability to identify a person. So usually when we talk about authentication, we talk about Facebook, we talk about Twitter, the username and password. That's what authentication is, the ability to identify the person, which is usually by the means of a username and password. So in a conclusion, Active Directory is an authentication and authorization system for Windows machines. Now, just to show you a quick overview of what an Active Directory is, an Active Directory is something like this. It's simply a Windows machine, like It's simply a Windows machine. But the one thing that is special about this Windows machine is when I, for example, log out, when I sign out, okay, instead of entering just the password, I have to enter the username and password, and the username should be a part of a group. Okay, let's not do that because it's gonna be a pain. Okay, so we're gonna see it later more. Like you're gonna understand it more later. But I hope that the definition that I just told you, which is a system made by Windows, by Microsoft for Windows machine to restrict access to machines, to other machines, to, for example, company machines. That's the basic idea, and to services, of course. So what are the elements of an Active Directory? First, we have the Active Directory data store. First, we're going to talk about the physical elements that are elements that we can actually touch and see and all that. So first, we're going to talk about Active Directory data store. An Active Directory data store is like what you understand from the name of the element, is the place where the Active Directory stores all the information as objects. So, for example, all the users in the Active Directory are stored in the Active Directory data store as objects. All the machines also are stored in the Active Directory as object. All the services that are found in the Active Directory are also stored as objects. Everything is stored in the Active Directory data store. As said, user machines and policies are all considered objects in the Active Directory data store. And one of the most important files in the Active Directory data store is this file, ntds.dit. This file contains everything about the Active Directory. So as a conclusion, if you contain this file, if you get your hands on this file, you get your hands on the Active Directory. And usually when people penetration test the Active Directory, the goal is to get to this file. The second thing I want to introduce is the domain controller. Okay, so the domain controller is the MOIC in the Active Directory. What is the MOIC? It's the mother of all computers in the Active Directory. So when you hear the word domain controller, think it controls everything. It is the thing that controls the Active Directory. The domain controller also contains the Active Directory data store, and it is the computer responsible for the authentication and authorization of everything in the Active Directory. So, as a conclusion, a domain controller is a server. It's a computer. It's a server that contains the Active Directory data store, and that is responsible for everything, authentication and authorization, things related in the Active Directory. Okay, now we're going to talk about the logical components of an Active Directory. So first, we're going to talk about an organizational unit. Okay, so as we said, we have a domain in our Active Directory. We have a domain controller, and then we have machines. For example, let's say we are in a company. There is the domain controller, the server that controls the Active Directory, and then we have the machines, which are machines used for the employees to work. Okay, and each employee has a username and password, so he can use the machine. So the organization unit is a logical container, and it applies policies on a group of users. So let's say that we have in a company we have like group. For example, we have engineers that work on the back end, or engineers that work on the front end of a website, or we have people in the advertisement section in the company. All of that. So in order to apply policies for this group of people, we use an organization unit. So it's like a logical container, and every user inside this organization unit have the same policies applied. Are applied on them. So that is an organization unit. It's like a logical container just to apply policies on a specific group of people. A domain is also a logical container, but it's a bit bigger than an organization unit. So when you think about domain, you think about the organization unit are stored inside the domain. Okay, so a bunch of organization units can be found inside the same domain. You can see that from this picture. Okay, and each domain has a name. For example, the domain that we're gonna work on right after this presentation, we're gonna have a small demo. The domain that we're gonna work on is cybercc.local. Okay. Now we have tree. Okay, tree is just a bigger domain, like it's a place that groups multiple domains. And all domains in a tree share a namespace. What do I mean by a namespace? So for example, let's see here this small picture here. So for example, let's say this is a tree, and each triangle in this picture is a domain. So as we can see, all the domains share a common name, which is company.com. Here we have hr.company.com, corp.company.com, uscorp.company.com. So as you see, there is a common namespace which is company.com, and then there are extensions on that namespace. So that's just the idea of this. And every node in a tree can have a children, as also seen from here. Company.com, its children are hr.company.com and corp.company.com, and the child of corp.company.com is us.corp.company.com. Okay? And every domain in the tree creates a two-way trust with another domain in the tree. Let's leave that for now. I will explain it in the later slide, in the slide after this one. Let's just leave that. Just remember that every domain in the tree, inside this tree, have a two-way trust with another domain in the tree. Just keep it in your mind for now. And finally, we have forests. Forests is just a group of trees. So we have organization unit. Inside, we can find them inside the domain, and the trees we can find inside the trees domains, and we can find inside the forest trees. So just that's the gist of it. Finally, when we talk about logical components, we're gonna talk about trust. So there is so what do we mean by trust? It's a mechanism to gain access to the resources in another domain. So let's for example say we have this domain and we have this domain. This domain has resources that this domain needs. So what will happen? There will be trust between these domains such that this domain can access the resources in this domain. There are two types of trust. There's the directional trust, which is that the trust flows from trusting domain to the end. Trust flows only from one direction. So for example, let's say that the trust flows from this domain to that domain. So this is the trusting domain, and this is the trusted domain. And the access flows in the opposite direction of the trust. So for example, if the trust flows from this domain to this domain can access things that we can find in this domain. So that's the idea of a directional trust, or one directional trust. Two-way trust is that both can access everything. And the idea about a two-way trust is if this is in two-way trust with this, so this domain is a two-way trust with every domain. This is a two-way trust with. So this is a two-way trust with this. This is a two-way trust with this. This is a two-way trust with this domain. So that's the idea. So like it spreads. Everything clear until now, or am I going too fast? Or
no, it's
هنا أنا عم
perfect.
بكتب
okay.
بكتب بس
Guys,
عم بكتب على
حدا
الشات.
عنده مشكل بالسرعة أو شيء؟
لا
Any
عادي.
problem, guys?
لا تمام.
No, it's fine. كثير منيح.
And if okay. If
فينا
there
نقول
any
إنه كل دومين هو يوزر بالأكتيف دايركتوري.
no, not every domain is a user. Like a domain contains many users. Like for example, like the example I give you about a company, there is a domain control, and then there are machines for the employees to use. Okay, let's say that there is an HR section, like there is an HR section in the company, and then there is, for example, a marketing section. Then there is the engineering section. You can if the company is large enough, every one of these has its own domain. If the company is small, all of them are in the same domain. Like it doesn't matter.
It's like subnetting.
Yes, this is the best example. This is the best example. Like you can consider each subnet its own domain, and the whole network, it's like the forest. So that's the idea. An organization unit can be considered something like a VLANs or something like that. This is the idea of if we want to compare it to something, we can compare it to this. Okay. And the last element about Active Directory logical components is the Active Directory schema. The Active Directory schema is like the blueprint of the Active Directory. So it's like the map of the Active Directory. Like if you want to map the Active Directory, you do the Active Directory schema. In the Active Directory schema, we can find what the things that I can find inside the Active Directory, which are divided into two groups. There are the class objects, which define what objects can be created in the Active Directory. For example, the users are an object, the computers are the object, the policies are an object. And there's also the attribute object, which shows us the information that are attached to the objects. For example, the name of a user, the name of the machine, the details or the details of this user, the details of this machine, and all of that. So this is the Active Directory. It's like the mapping of the Active Directory. Okay. Now we have finished defining what an Active Directory is. Hopefully you have now a clear idea of what an Active Directory is. Now we're gonna speak about the protocols that you can find in the Active Directory. And the first one of these protocols is an LLMNR, the LLMNR protocol. So what does this protocol do? So the idea of this protocol is that, let's say we have a user, okay, that wants to access a resource, okay? Just like websites, we have Facebook.com. It's a domain name. It translates into an IP address. For the people who don't know, that's what actually happens when you print www.facebook.com. This domain name translates into an IP address, and then you connect to Facebook. Just like this happens in the website, when you connect to a website, the same thing happens when you want to access a resource in the Active Directory. So the idea is you request the resource. For example, here I'm requesting a resource named hello. So the idea is, how do we resolve the name of this resource? So the thing that happens is that first, the client sends a request to the domain controller asking, okay, I want to access this resource. Do you have it, or do you know where it is? Let's say that the domain controller said, no, I don't know. I have no idea where the resource is. When this happens, what this computer does, it sends a broadcast to every other computer in the network, telling them, okay, I want to access this resource. Do you know where it is? For example, let's say it sent it to this computer. This computer also didn't reply, no, I don't know it. It sent it to this computer, and this computer said, okay, I know where it is. But before I tell you where it is, please send me your credentials. Please send me your username and password so that I know that you're inside my domain, and so that I know I can trust you. So this guy sends the username and password, and in return, this computer resolves him the resource that it requested. So the idea of the LLMNR protocol is that it is a protocol used to resolve domain name issues or service name issues. So if a service name cannot be resolved by a domain controller, this is what happens, the LLMNR protocol. But usually the domain controller resolves these issues, like knows where it can find this resource. If it doesn't, this is what happens. Everybody got an idea, everybody understood the LLMNR protocol, because it is important, because later on we're gonna see how to attack this protocol.
Yes.
If anyone has questions, please ask.
Ahmed, you have any question?
ال LLMNR بروتوكول بيشتغل بعد ما السيرفر، بعد ما الدومين يقول له انه انا ما بعرف شو وين هيدا الريكوست عندي.
Yes.
اوكي، يعني من بعد phase 1، من بعد المرحله الاولى، من بعد ما يقول له انه no I don't know where this is, where this request is.
All of this is the LLMNR protocol. All of this, like the idea of resolving the name, it's the LLMNR protocol. Like it's similar. It's
like
to
DNS.
Yes, it's the DNS, but for the Active Directory.
Okay.
Okay. So this is the LLMNR protocol. Now we're going to talk about a much more complicated protocol, which is the Kerberos Protocol. So what does the Kerberos Protocol actually do? So let us consider the same scenario as always, that we have a company, and this company has a domain controller and other machines, which are employees. Employees use the Active Directory to access their machines. Let's say that one of the users or one of the employees is an IT, and he wants to access a resource in the Active Directory. Let's say, for example, he wants to access the SQL service. So the idea is, to access the SQL service, he has to initiate the Kerberos protocol with the domain controller. Okay, now what actually happens in the Kerberos protocol? So the first thing that happens, this is the machine. The client C is the machine of the IT, and he wants to access the SQL service, which is this server. Before it, the idea is that the idea of the Kerberos protocol is that it can't access directly the SQL server. Why? Because maybe for one, maybe this guy isn't actually in the domain control in the Active Directory in the domain. So what rights does he have to access the SQL server? That's the first point why we use the Kerberos protocol. And the second point is, who told you that this guy even has the permission? Even if he is in the Active Directory, who told you this guy has the permission to access the SQL server? So this is the idea of the Kerberos protocol. It controls these two aspects. Are you in the domain? If yes, do you have permission? If yes, go ahead, access. That's the idea. So what actually happens in the Kerberos protocol? The first thing that happens is the client sends a request to the domain controller. Okay, the domain controller is divided into two servers. You can consider it's divided into two servers. The first is called the authentication server, which by its name it authenticates the user, and the second it's called the ticket granting server. We will see now what it does. This server. But all this is called it's still the domain controller. Okay, so the idea is client C sends its credential to the authentication server. So it sends its username and password to the authentication server, and it tells the authentication server, okay, this is my username and password. Check if I'm in the domain. The authentication server checks if it's in the domain and sends back a message. What can we find in this message? We can find the client name, the address of the client, the validity. Is he in the server or not? The validity is just to for security reasons. It's like a signature to check to, like, the server signed this this message to say that it's okay. I signed this message. It's message made by me. No one other than me did this message or sent you this message. So that's the validity. And this message also contains a key, which is a temporary key sent by the authentication server to the client in order to start the request for the service. So that's the point of this key. It's called it's a session key between the C and TGS. So, and this message is encrypted by the TGS, by the private key of the ticket granting server. I don't know if you're understanding the encryption concepts, but the idea is this is the most complicated part of the presentation. So if anyone has any question, please ask. So after you send the credential,
Ahmed.
Is the Kerberos protocol dependent from the LLMNR?
Yeah, they are two different protocols. They just work together in the Active Directory. Like
the encryption technique in the Kerberos protocol, is it the same like in the HTTPS?
Well, actually, I don't know, because there are many types of like HTTPS uses a lot of protocols. Like there is the TLS, there's the SSL, and there are multiple versions, and each version they change something. So actually, I'm not sure if it's the same, but I don't think so.
It's a UDP protocol, right?
This?
Yes.
No, it's TCP.
Okay.
So the idea is that, okay, so after sending the credentials, okay, the server sends after sending the credentials, it checks in the authentication server. There is like a database and inside this database we have the key of the client. Okay, so it sends back a message containing the client, the name of the client, the address of the client, and a signature of the authentication server to make sure that this message is sent by the authentication server. And also we have the session key between the client and the TGS. It's a temporary key sent by the authentication server to do the Kerberos protocol. This is encrypted by the key of the ticket granting service server. And there's also another message sent in this back to the client, which is the key encrypted by the key of the client. So the green key is the key of the client, the yellow key is the key of the TGS, and the red key is a temporary key between the client and the TGS. Okay, now when the client C received these two messages, the first thing he does, he decrypts the message A, he gets the key, and now what he does is he sends back the exact message that the server sent him. He sends it back. Why? Because he can't do anything with it, because it's encrypted with the key of the ticket granting server, and the client doesn't know the key of the ticket granting, so it's useless to the client. It's just a message for the ticket granting server to decrypt. And he sends also the client name and the timestamp. Why does he send the timestamp? Just as a precaution, because if someone sends the message again, the same message again, like the ticket granting server knows that this message was sent before, and this is a replay message, so he just drops it. And these two messages are sent to the ticket granting server. The ticket granting server decrypts the first message, which is this key, the client, the address, and the validity. And he knows that, okay, the authentication service actually authenticated this client, so this client is in the domain. Great. He also decrypts this using the key found in this message, in message C. He decrypts this and he checks if the client is the same. Okay, so the client that the authentication server authenticates is the same as the client that is requesting the service. Okay, great. Now we can give him the ability to request a service. So what the ticket granting service returns a message to the client. Inside the message, what do we have? We have the exact same as the before, the client name, the address, the validity. But this time it is encrypted with the key of the server. And inside it, there is also a temporary key that is used between the client and the server. And also the same as with the authentication service, we have this key encrypted with the session key. So the client gets this message, he decrypts the message F, he gets this key, and he sends back this whole message with the client and timestamp, the same as before. The authentication service sees that this message is the ticket granting server gave the client the okay to use the service, so everything just starts. The communication between the client and the service commences. This way, the client can access the server. Okay. Did you understand the protocol, how the protocol works?
Yes, clear.
Guys, إذا في عندكم أي شيء تعليق، إذا في سؤال محدد خاصه بهيدي البارت فيكم تسألوا، بس إذا شيء عمومي I think إنه we can leave it to the Q&A session.
I know it's a bit complicated, but
we can proceed. Thank you.
I know it's a bit complicated, but no. Yeah, this is a protocol. If you understand, it's simple, but the protocol itself is a bit complicated. Okay, one thing to note is that this message B, which can be seen also here, is called the ticket granting ticket message, TGT message. And this message and the message called E, it's called the ticket granting service message. Okay, the naming sucks, but that's how they named it. Why they named this TGT? Because this is a ticket that grants a ticket. And why do they call this TGS? Because this ticket grants a service. Okay. If everything is clear, now we're going to start with the actual attacks. Okay, so this is the LLMNR scheme that we talked about. Now, does anyone see a problem with this scheme? Does anyone know why?
Because there's no authentication.
What do you mean there is no authentication?
There is a problem.
Which is?
Sorry.
anyone speak.
مثلا يمكن البي سي واحد يقول له مثلا انه انا عندي هيدي الكريدنشلز ويبعث له
No.
الانفورميشن
Which
تبعه.
PC? Which PC? Any one of these.
تحت
Okay.
هيدا البي سي ايه
Uh,
ممكن يقول له مثلا انا عندي الكريدنشلز تبعولك ويبعث له هو كل شيء انفورميشن تبعوله وهو ما يكون عنده شيء.
exactly. That is the problem that we can find in this topology, which is that the user that wants to resolve this domain name, for example, the domain name is called share01. It sends this to the domain controller, which the domain controller in the Active Directory is the domain name server. The domain name server tells him, no, I don't have it. And the attacker, when the victim broadcasts this to every computer, we are like in the network, and we tell him, okay, we know how to resolve it, but please send us the credential before we resolve it. The victim, like a stalker, sends us his credential. We take the credentials and we tell him, sorry, we don't have it. This is a way, like we take advantage of the LMR protocol, which is a very crucial protocol inside the Active Directory to get user credentials. And this is what we're gonna see in the demo right now. So okay, now we're gonna show you how the attack is done. So to do the attack, we're gonna use a tool called Responder. This tool, as its name suggests, it responds to requests. So if the tool sees a LMNR request, it responds to this request and it gains us the credentials. So we're gonna give this tool as an input the network card that we're gonna use to do this attack, and we're also gonna send some additional parameters that are uninteresting, and it starts listening to the things that are happening in the Active Directory. But first, before that, just keep in mind that we are in the same network as the Active Directory. So we just got it. For example, if the company tells us, okay, you have to make penetration testing for us, you just plug the laptop, and this is the first thing that you do. You just start Responder and start seeing if somebody wants to resolve a name of a resource that the domain controller can't resolve. So now let's just simulate that. Okay, so this is a user, and let's say that the user wants to access a resource that the domain controller just can't resolve. So let's just say hello. Okay, it's gonna start communication with the domain controller. The domain controller can't resolve it, but our computer can resolve it. And this is what this is like an attempt that the attacker, like this is the attempt of the attacker to resolve the domain name. And we, on the other hand, wait a second. Let's remake this. Okay. Okay, and we get the hash in return. So, does anyone know what a hash is?
Yes.
Okay, can you explain it to your friends?
هاش هي مثلا شغله عاملين لها انكربشنز بتصير اصغر بتصير هاش صح؟
It's the idea is correct, but it's not an encryption. It's just a function. It's a one-way function where no matter what the size of the input is, you get a fixed output. And
دكتور
it's a
انا
one-way
كثير
sorry. So the idea is of a one-way function is that no matter the size of the input, the size of the output is fixed. So and it's one way. So if you have the output, you can't get the input. But if you have the input, you can get the output. So this is a hash. Okay. Now when we we made the LMNR attack, and we got the hash of the user called Felix Trap in the domain CyberCC. Okay, and this is the IP address of the client. Okay, now what can we do with this hash? Well, in fact, we can try to resolve this hash. We can try to find the password. How? We're going to use a tool called Hashcat. So the idea of this tool, which is Hashcat, is that it helps us. It tries. For example, we give this the Hashcat as an input a list, and it tries to hash every one of these words in the list, and see if the hash that we have and the hash that it made are the same. If they are the same, that means this is the password. If they're not the same, that means we didn't find the password. So this is what Hashcat does. We're gonna input the hash that we found. We're gonna put it here, and then we're gonna try to use Hashcat. So I'm gonna give this Hashcat the type of the hash, which is just this is the name of the module in the Hashcat. So this is the type of the hash that we're gonna try to find or to resolve. We're gonna send it also the name of the file which the hash you want to resolve is found in, which is in our case password.txt. We're gonna also send it the list that we're gonna, like this list that I just showed you, the list that we're gonna, the Hashcat will try to hash every one of it and compare it with the thing that's found in password.txt to see if this is the password. And in the end, we're just gonna give it a parameter to optimize the search. And it will start decrypting it. It will take like 10 seconds or something like that. No, shut up. Okay, and it found the password. This is the password of the user. So we found a password of one user, which is the user called Felix Drap in the Active Directory. Okay, cool. So this is the LLMNR poisoning. This attack is called LLMNR poisoning because we poison this this exchange by saying that we have we can resolve the address, and in return we get the credentials of the victim. We get the password of the victim. The username is of course Felix Drap. So that's easy. Okay. Now why did I do the LLMNR protocol before? Why did I do the LLMNR attack before the Kerberos attack? Because in Kerberos attack, we're gonna use the credentials that we got in the Kerberos protocol. Now, in this attack, where can we find the vulnerability, the problem? Where is the problem? It's less obvious, but there is definitely a problem here. Can someone spot it?
Last step.
No, the last. Okay, where's the problem? The last step.
انه we have 1K تحت حد الباسورد.
Where?
آخر شيء هون.
Yeah, here it's the connection has initiated. The connection between the client and the server started. Like
okay.
it's not.
The problem is that the blue key. If we have the blue key, we got the service, right?
Yes, if we got the blue key, we got the service. Yes, okay. If we got the blue key, we got the service. Okay, but okay, we gained access to the service. Okay, but like we didn't.
Maybe has an answer.
The key is encrypted.
What key?
The key that the server gave us is encrypted. We can't know what is the key.
What key? Like what color?
Red.
Red. Okay, we can't know this key. Why you can't know this key? It's encrypted with the key of the client, so the client knows the key, the red key.
The client knows the red key.
Yes, it's in here. The green key is the key of the client, so the client can get the red key. If he can't get the red key, this whole thing is impossible. Impossible.
Issue في الميدل ستيج you can request multiple TGS وتاخد الهاش and you can crack it offline.
Okay, but I told you that the timestamp is what prevents that. Like the timestamp prevents, since if two messages have the same timestamp, then this is a problem. The TGS can.
Maybe the key that is sent to the user would be sent from the attacker.
No. Okay. So the idea, which is less obvious here, is that this is the Kerberos protocol. So the first thing that happens, as said, the victim sends us the credentials and requests a TGT. The domain controller sends back the the domain controller sends the TGT encrypted with the session key. Then the victim sends back to request the TGS. Now here's the problem. When the domain controller sends back the TGS, which is this step, when the domain controller sends back TGS, it's encrypted with the server's account hash. Okay, now we can somehow leverage this to get the server account password. Well, as said here, it's less obvious, but there's still a problem. Okay, now of course I don't think you can you can imagine what I mean by this, but let's try to do the attack right now. So to do the attack, we're going to use another tool. Okay, this tool is called Get User Spn. It's a script, not a tool. It's a Python script. Okay. So what this tool does is it does the Kerberos protocol, and when it receives the TGS, it just stores it inside. Like it doesn't send anything to the server or anything. It just stores it inside. It just stores it inside the user. Okay. And we, as I told you in the first step, we send the credentials of a user inside the domain, which we actually have, which is the user of Felix Drap. So that's what we're gonna do. So the idea is this tool. We're gonna input the name of the domain, the name of the user, and the password of the user. Okay, the IP of the server, which we're gonna get by logging into the server. We can get it, of course, using tools such as Nmap or something like that, or just network searching tools. But let's not make it a bit complicated and just get the IP address from the command prompt.
Do you have any question?
Isn't the attacker in the network? Can't he ping the victim? The attacker, isn't he in the same network? Doesn't he? Does he can ping the victim?
Yes, he can ping. The attacker can ping the victim. Yes, he can ping the victim.
So there's no need to use the Nmap, right?
Oh, yeah. No. The Nmap is just to get the IP address. Like, okay, you can ping every IP address inside the network, but this is what Nmap does. Like, how will you know the IP address of the server?
Yeah, right. You're pinging the broadcast like every client in the network.
Yes, you're pinging, like in Nmap. What do? You give it the network address, and it just pings every client in the network address. If the client gives a response, then there exists a client in that IP address. So we know that there is a client in that IP address. So you know the IP address of all computers in the network.
The attacker is in the network. It's another topic here. How he got into the network, right?
What did you say?
How did the attacker got into the network? It's another topic, right?
Well, usually what happens is the company that tells you to to test her Active Directory just gives you access to the network. So, like, if this doesn't occur, then all this can't happen. Like,
yes, like if I'm a bad guy, I have to go into the router. I have to hack the router so I can get into the network.
Exactly.
Yes, exactly. but that is almost impossible because there is nothing and many other things. So the only possible way, like, okay, you can see it's hard, but it is possible to bypass nothing, but it's insanely hard. The only way I can actually do all this if someone gives you access to the network. Okay, there are many ways, but that's the only way.
Social engineering or something
like
that.
even social engineering, it's hard. If you're outside the network, if you're not in the same building, it's as the network, like it's hard even with social engineering. Like the only way I can think of is just for example, when one of the employees is outside of the company, you can just upload a shell or something like that, and then do everything from the computer of the employee. So that's the only way I can think of.
Yes, thank you for the clarification.
Okay, so this is the IP address of the server. I'm gonna copy it and we're gonna print it here in the comment. Okay, and then we're gonna. Okay, so this is the command that we're gonna use. So the idea is that we're giving it the domain that it's gonna attack, the name of the user that it should send that it should use to send that ticket ticket request, the password, that means the credentials of the user, where the ticket where the domain control is to know to where to send the request, and then we're gonna say we want to send a request. So wait, what? Can't open file. Message file directory. What the fuck? SPNs. Okay. 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 So this huge, humongous thing is a hash. That Hashcat can help us. That Hashcat can resolve in order to find the password of the SQ of the service that we're trying to like. As I said, that the service that we're trying to access has a username as an object in the Active Directory. So this is the password of this username of this user, which is the SQL service that we're trying to attack. So we're just gonna do the same thing that we did before. We're gonna copy this into the here, save it, and we're gonna use the Hashcat to do the same thing. But now we're gonna just use a different module. Which I forgot what it was. The module is, I guess, this one. Okay. So the module is 131. Now it's gonna try to crack it. Okay, and it found the password also of the server, which is this. Okay, now what we found here is the password of what? Of the apps of the service. So this, as I said, the service has a username and the password inside the Active Directory. We have found the password of the service. Okay, now the question is, how does this benefit us? Okay, the way that this benefits us, in fact, is that usually when ITs create Active Directories, they're too lazy. Well, that's what all ITs are. Like usually when there is, like, when something goes right, when we program, when something goes right, we don't ask, okay, is there a way I can optimize the code? We're just, okay, it's working, just let's not mess it up. That's what we usually do. So the same happens with IT. Like they don't know like all this stuff. these stuff are a bit complicated. So the idea is that usually when an IT makes the domain controller, he gives the service account administrator privileges. Okay, you're like, okay, how can we get, okay, what does this mean? This means that this server account can be used to access the domain controller. And if we access the domain controller, we access what? The entire Active Directory. In other words, we own the Active Directory. And this is what I'm going to show you right now. So what we're going to do right now is we're going to use the username and the password of the SQL service in order to gain access to the domain controller. Okay, before that, let's just enter the domain controller, and inside the domain controller, we're going to put a file so that we know that we're inside the domain controller. Say we're going to put a file called here in the desktop. Hack. Okay, and inside it, we're going to just write something like hack. Okay. Wait a second. Okay, so okay, search. Okay. So what I'm doing now is I'm using a predefined exploit in order to access the domain controller. Okay, so I will input to this predefined exploit. It's a Python script, so I'm gonna load into this Python script the parameters, which are the IP of the host that I'm gonna attack, which is the IP of the domain controller. I input it somewhere up there. This is it. Okay. And I'm gonna also give it the domain name, SMB domain, which is cybercc.local. I'm gonna give it the password, SMB user first before the password user. It's SQL server. We can find the user from the hash that we found up there here. This is the name of the user, SQL server, and the password. Finally, SMB pass, which is the thing that we found here. And we're gonna exploit. Okay, wait a second. Okay, so it didn't work, but that's because of this. Okay, but it should work. So the idea is that once you do this, you should have access to the Active Directory. You should have access to the Active Directory, to the domain controller, and that's it. And once you have access to the domain controller, you have access to everything. Okay, now before I end the presentation, I just want to note something, is that everything you learned here is bad, like hacking knowledge. So, as the footer said, the cyber community cannot be held responsible for any unauthorized action performed by one of its members or participants of this session. So everything you do from the knowledge you gained here, we're not responsible of it. Never say that cyber community told us this shit. We're not responsible for anything. This is just knowledge to protect. Like
Yes, yes,
in case someday someone told you to pen test something, or in case you someday configured an Active Directory, you know of these attacks. You know how to protect yourself from
for
these
sure,
attacks.
for sure,
And
for sure.
that's it for the presentation. So does anyone have any question, or I'm disconnected a long time ago?
All right. Okay, فكرت ما خلصت. So guys, that's the session. Let's go now to the Q&A session. If you have any question, please raise your hand. We start with Ali Zaiter.
Yes, regarding the second protocol, but the problem wasn't so clear. Can you بس هيك بشكل مختصر بس تقول لنا يعني؟
Yes, the problem is that okay. So here, when the ticket granting server gives us back the TGS, it is encrypted with the key or with the hash of the SQL server. This key is the hash of the SQL server. So we can use this somehow. Like we can get this ticket granting server, and we can use it somehow to get the password. Like Hashcat can, from the ticket granting server, get the password of the service. That's the only that's the problem.
اوكي كلير. بعد في سؤال بس، الهاش هودي الباسوردز الهاش عم تاكد منه كنت هودي اكزامبل صح؟ انه مش حيلا باسورد فيك هاش يكون فيك
Yeah, not any password does hash. Okay, now this is a very important topic that you just said. Okay, like a lot of you are right now thinking, okay, all of these attacks are under the impression that the password of the company is using, or the user is using inside the company, is weak. It is crackable. It is predictable. Okay, you're like, okay, the companies, the employees in the company are not that idiots to use such weak password that can be easily dehashed using Hashcat. But you can't imagine, like, okay, I'm not an expert. I never worked at a company, but I know people who worked at a company, and of course, when I was learning all this, I asked them the same question. Okay, the companies aren't that idiot to have such weak password policies. But you would actually be surprised that all of them replied me with the same answer. Like they were laughing hysterically. Like they were laughing so hard, like just because I was clueless about how clueless are the companies and how weak the passwords of the companies are. There are a lot of companies that use passwords like the name of the company, the name of the road, and at the ID of the employee, like or the name of the company hash the ID of the employee, or something like that. You're just like, that's how clueless the companies are. Like they think these passwords are so complicated and that they're so hard to crack, but in fact, like any person with a bit of experience in this domain can easily predict what the password is. So yeah, that's the highlight of this point.
Yes.
Zainab, تفضلي.
First of all, I would like to thank you, Mr. Karim, for this amazing presentation. Second, I have two questions. The first one, can't we use the traceroute instead of IP configuration in CMD, or traceroute is just used for links?
Traceroute is used to traceroute is mostly used for to see how the message goes. Like you say traceroute and an IP address, like let's say not the IP address of my machine, the IP address of another machine, and you know what problems are on the road. Like you know where the packet, for example, if there is if ping doesn't work, you know where the problem is along the road. Like it shows you how the message goes from your machine to the machine that you provide the IP address of. That's the role of traceroute. In my case, I just wanted to know the IP address of the server, which I'm already on. So that's why I use ipconfig.
Okay, and my second question is, what is the name of the applications that you use, terminal and this?
This is not an application. This is an operating system. It's a Linux operating system called Cal Linux.
What's the name, please? Or can you write it in the chat?
Chat. Okay.
Thank you.
As I said, it's not an application. It's an operating system called Linux. It's called Cal Linux. It is used by pen testers usually because it has all the tools that you need to pen test.
So Zainab, if you don't want to buy another PC, you can just download a virtual machine and download the operating system, so you can use it if you want.
Yes.
علي حمود تفضل.
You said that most messages that is sent to receive a certain service is encrypted. Would there be a certain problem with the encryption process in the Kerberos protocol or any other protocol?
I doubt that there is problem with any encryption protocol, because when companies usually use encryption protocol, they're most certainly sure that there aren't problems with the encryption. Like as I said, it's just that the way the message, the ticket granting server is constituted or is built, it's faulty a bit, so that we can find through it, we can find the hash of the server's account, and thus we can find the password of the server's account. But the encryption method, I doubt so much that it's faulty.
Okay, thank you.
We have one last question with Ahmad Auji.
Thanks, Kareem, for the valuable information that you have gave us. But I have one question: is that the Hashcat tool, is
Yes.
it dependent on the odds you wrote before you run the tool? Is this tool dependent on the odds of the passwords you wrote before?
Like the idea is that you provide this tool with a word list. With the word list, usually what companies do is that they give you word lists that they have. Like the word list that I use is so simple, and I won't lie to you, I added the password of the account that I used inside this word list to make this work. But usually what happens is that companies have their own word lists, and companies have their own tools to create word lists. So usually the word lists that they provide you with are sufficient enough to crack passwords of other companies when you pen test. But as I said, I provided beforehand the word list that I used with the password of the users. Like I don't know where I provided them, but I somewhere for sure provided them. Somewhere deep down.
في database online I guess في كتير
Are
اشياء.
these words randomly?
No. The word list that I'm using is a very simple word list, and this word list have the top like 1,000 or 2,000, like I don't know, 10,000 passwords that are used online. So that's the tool word list that I used. But as Ali Zaiter said that I guess Ali Zaiter said that we can find a lot of word lists online that are like 20 to 30 gigabytes big, so you can use those.
All right. So is there any other question, guys? Ahmad?
Kareem,
Ahmad,
I've
you
been
have any
engaged.
question?
Yes, I've been engaging in the penetration for a while, and I need some advices, please.
Okay.
Are you hearing me, Kareem?
Yes, now I'm hearing you. Like you're now muted for some reason.
Yes. I signed up for the INE program. It's called the PTS, Penetration Testing Student, at the INE. And do you think it's helpful, or do you have any?
I actually don't have any information about the program you signed in, but for some reason, like 2 or 1 day ago, someone sent me like that there is a company called Cyber Talents in cooperation with IEEE is making a 3-month training program for students in the cybersecurity domain. And Cyber Talents is a company that actually I like I know personally, but I don't know how good is their course. But I know that the course is for free. It's 3 months during the summer, so like, you can check that out if you want.
Can you please write it on the text box?
I don't know if I can send Hadi the link to send it to you all, because like
Yes,
it's on WhatsApp.
I think I know what he's talking about. I'm just gonna check it.
Because
Just
I
let me check.
I think the Hussein Kazem, which is the president of RTP and the Faculty of Engineering, Lebanese University, sent it to me. Yes, Cyber Talents.
Yeah. I have the info about it.
Yes.
Hi, Kareem. Thank you for mentioning me.
Okay, so
I don't know if you guys can hear me. I have.
Yes, we're hearing you.
Could you hear me, Karim?
Yes, I can hear you.
Ahmed, if you can contact me on WhatsApp, I'll put my number now.
Yeah, for sure,
I'll talk to you.
Yes, I have your number.
Hassan, you want to say Hassan Kazem?
Were you talking to me?
By the way, guys, Hassan Kazem is the chair of IEEE at the Lebanese University, Jama Lebanese. Hassan, we can't hear you. هلا إذا كان بدك تقول شيء.
Okay, now.
So, can you send us the link, please? Guys, don't worry. Anyone who wants more details about this course, just contact me. I'll provide you with more information about this. Okay.
I think you can also you can also find it in the IEEE Lab Instagram page.
Hadi, I'm sending the link in the chat right now. It's on IEEE Lab Instagram. I sent the link in the chat.
Yeah.
Okay, so you can find it in this page, like the link and the description of this course. It's from what I heard, a 3-month training program. It's 100% free. It starts from 1 June to the 1st of September, and I know that Cyber Talents is a bit like a good Arab company for cybersecurity. It's very famous in the Middle East region, so you can just check the course out.
Exactly, guys. Exactly, it's available. Actually, IEEE Lab بعد ما بلشوا activities. That's why ما كان بدي ابعتهم على الصفحة. No problem, no worries. So, guys, if you don't have any more questions, then we may conclude this amazing event. Thank you so much, Kareem. Thank you, Hussein, the chair of IEEE Jama Lebanese, and also the vice chair of cyber community. I think the vice chair, yeah. So also thank you so much, guys, for attending today's webinar. Don't forget to follow us on social media, IEEE LIU Student Branch. We're available on Instagram, Facebook, LinkedIn, YouTube, and WhatsApp group. And this event will be uploaded on YouTube, so you can invite your friends to check it out. Also, as I already said, all user resources will be available in the description of this event once uploaded on YouTube. So that's my number and the number of the vice chair, Omar Banat. I'll put it now in the chat.
I think إنه هادي صار عنده شي مشكلة. حاحط الأرقام أنا وأي حدا عنده سؤال بيقدر يحكيها.
Okay, thank you very much for watching the session. Goodbye.
Thank you very much.